Okay, so let's take a look at this one, see how you're doing with it. The first one over here, let's decode. Find the range that this code stands for. So yellow stands for what?
4.
4. Green stands for
5.
5. Now the third digit, guys, stick with me. The third digit tells us how many zeros. Orange stands for
3.
3. So that's 10 to the third, or 3 zeros. So that is 45,000 ohms. Silver means plus or minus
Plus or minus 10%.
10%. So now the next thing we have to do is figure out what 10% is. I mean, 10% is a relative or percent allowance. We need an absolute allowance. So 10%, 10 out of 100, is how much out of 45,000? So we are going to cross multiply and divide. 10 times 45,000 and divided by 100 is 4,500. So to get our range, we're going to start taking the 45,000 minus 4,500. Gives us 40,500 is the bottom end of our range, ohms. To the top end will be 45,000 plus 4,500. Giving us 49,500 is the top end of our range. So there is our range right there. How many of you had that one? Just a couple of you? Yep, go for it. The second one here, to color code that, before we can color code that, we have to have a desired value and an allowance. Now we need to convert the allowance into a percent. So to find the desired value, we're going to add those together. And divide by 2. Now a warning, when you're doing this on your calculator, when you add them, hit equals before you divide by 2, or it's going to give you some funny stuff. That ends up being 240,000 ohms. That is our desired value. To find the allowance, then, we subtract those. 288,000 minus 192,000. And we divide the difference by 2. And again, make sure you hit equals after you subtract before you divide by 2. Which is going to give us what? 48,000? Then divide by 2, yeah. So 288,000 minus 192,000, hit equals, and then divide by 2. Otherwise, it's just going to divide the second number by 2, and then subtract it. Okay, so what we have here is 240,000 ohms, plus or minus 48,000 ohms. So now we have to figure out what percent that 48,000 stands for. So blank over 100 equals 48,000 over 240,000. We're going to cross multiply and divide. 100 times 48,000 divided by 240,000 is 20. So this is 20%. So this is 240,000 ohms. Plus or minus 20%. So how do we color code that? Well, we're going to color code the 2, which is red. Then the 4, which is yellow. Then how many zeros? 4 zeros, which is yellow. Tolerance band, plus or minus 20%, is either no tolerance band or a black one. One of the two. Either one would be fine. Black can also be 20%, yes. Generally, though, they don't put a tolerance band on there if it's plus or minus 20%. Any questions on those? Okay. Like I said, if on a test or a quiz, I would make those extra credit, just because they're a great application of tolerances and allowances, but not something everybody has to know. Okay, our quiz dealing with micrometers and calipers. This group didn't do terrible on it. Didn't do as bad as some of the other groups did, but it's one of those topics that's important enough that I'd like you to know it a little bit better. So let's go through it. We're going to take some time today to go through those again. So this one, first thing we have to figure out is this standard or metric?
Metric.
This is metric. There's two ways we can tell. One, this goes from 0 around to 50. Even though it says 45, the 0 would be the 50 again. That indicates metric. If it were standard, the thimble would go from 0 to 25. Very good. And also here, this is labeled 0, 1, 2, 3, 4, 5. Each mark is 1. On the standard, each mark is a quarter of a tenth, or 25 thousandths. So looking at this, we have 5, 6, 7, 7.5, 7.5. And then what do we add from the thimble? Well, it's between the 41 and the 42, but it looks to be closer to 42. So 0.42, so that's 7.92 millimeters is what that gives us. Does that look familiar? So on this one, how many whole millimeters?
0.
1, 2, 3, 4. Do we go past the half mark? Yes, so 4.5. Then what? Between 46 and 47, it's closer to the 46. So 4.96 millimeters. Those are easy? We'll get to those. So this one, what does it read? 6.5. 0.33. Yeah. Close, a little bit closer to the 33 than the 34. So 6.83. This one? 6, 7, 8, 9.0. So you don't need the half. And 29. 9.29. That's it. Let's have you guys try a couple. Let's have you guys try these two. See how you do. Okay, so for the first one here, what is it? 10, 11, 12, no half mark, and then 0.21. This one is 13.5. It's past the half mark. And then 0.19, right? So 13.69. Oops. Is it 2.2? You're right, it is 2.2. Thank you. Is that better? My eyes are bad. 12.22. So how many of you had both of those right? 12.22, 13.69. Good deal. We got a couple more of those we can try here. This one is going to be 15, 16 point. Is it closer to the 7 or the 8? Probably closer to the 7. 16.07. That's one that a lot of you messed up on the quiz. There's always 2 digits, 2 decimal places. So if it's less than 10, it's 0.0 whatever. In this case, 0.07. Read this one for me in your notes. What'd you get?
18.07 millimeters.
18.57. This is 18. It is past the half mark. So it's 18.5 and plus 0.07. So 18.57 millimeters. We'll skip over those. Let's go to this one. What's different here? This is now inches because between 0 and 1 there's 4 quarters in there. We know that's inches. Also, you can't read it, but the thimble goes from 0 to 25 instead of 0 to 50. So this is 0.125. That's 1/10, and that's past the 25,000th mark. And this looks like 8 thousandths, 0.008. So that is 0.133 inches. Look familiar? So this one is 0.250 because we're past the second quarter mark. And plus, that was at 0.008 as well. 0.258 inches. Make sense? So tell me where to start on this one. 0.375, okay. And this is 11, so 0.386 inches. What's that? Yeah, well, it's tough because you're looking at a. The first thing, like I said, is determining whether you're reading in inches or millimeters. And of course, if you have the whole micrometer, it says right on the arm of the micrometer, 0.01 millimeters or 0.001 inches. So that helps. So this one, of course, is 0.475 and 12. So 0.487. Try to read these two on your own.
That one, would it be like the first one would be 0.015 or 0.001?
First one?
Yeah.
That's 0.550.
Right.
And then 0.015.
0.015.
Yep.
Let's try to keep getting confused.
See, that's what throws me off is I keep thinking it's 5 plus 1 plus 1, but actually it's 5, which is actually 10. So the one line would be 25 and then 50. So that's what kind of throws me off.
So this is 0.5 here. And then 2550, so 0.550. And this is 15. So this is 0.565 inches. How many of you had that one? Cool. This one then, this is 0.625 and 009. So 0.634. How many of you had that one? Good deal. We'll do a couple more, then we'll skip up to the next style. Oh, what's this one going to read? 0.750. 17, good. So 0.767 inches.
And It tells you like if it's from 2 to 4 inches or whatever.
Or 2 to 3, so you start at 2.
Yeah,
Yep.
so then just put like 2.75.
Yep. Exactly.
I think you got it down.
Here's one we haven't seen much of before. First of all, metric or standard?
Metric.
Yeah, you can see this goes from 0 to 35, so you know it goes up past 25, so this one has to be metric. This one, you can see the 5 there, so it's a little easier. This one, a little more difficult to see, but there would have been a 1 here if this was, there would have been a 1 here if that was standard, because it has to be in quarters, so we know that that one has to be metric. So this is 1 to 3.5, and we still read it at the 0 line here. This is 13, right? So 0.13, that is 3.63. What's this scale do? It just adds a digit on the end. What lines up? Well, the pink line is on, it's between 2 and 4, so that'd be 3. So 3.633 millimeters.
That was 16.
Well, this,
Something 15.
well, what matters is this side. This side is just, it has to line up with something over here, but it doesn't matter what this number is. Just that it lines up.
So then you just look at the left number.
Yeah. Like this one here. This is 5.6 millimeters. It's not past a half, so it's 6.0. This is, here's the 0 mark. This is 21 that lines up. So it's 0.21. So 6.21. But now on the vernier scale, it's also the 0 that lines up exactly. None of the other ones line up. So that's 6.210 millimeters. So that one's kind of tricky because the 0 lined up. So that wasn't a very good example. Let's try this one. So this is 11.5. So 11.5. Then what lines up here with the 0 is 17. So it's 11.67. And then this one lines up with what would be the 1. So put a 1 on the end of it. So 11.671. Make sense? So over here, 10, 11, 12, 13. We're past the 13. Now here we are between 8 and 9. Now it looks like we're actually slightly closer to the 9, but it doesn't matter because when we have a vernier scale, we always go to the smaller one. So 13.08. Then what lines up here is actually the 5. What this is saying is we're between 8 and 9. We're actually right at 8.5. 8.5 is what it's saying. Does that vernier scale make any sense to you? A little bit. It's kind of tricky, isn't it? All it's doing is adding an extra digit. It's telling you here when we're between the 8 and the 9, it's telling us how far between we are. You guys have a vernier micrometer? Okay, yours is probably an inch micrometer, though. Like this one, then. So this is 0.150. Then this is between the 10 and 11, but we always take the smaller one, so that's 0.010. So 0.160 right now. Then what lines up here is the 4, so 0.1604 inches. Looks like what you're using? You look confused, Marco. Okay. Well, again, what you do is this part here, you just absolutely ignore that till you're all done.
I've completely been ignoring that.
All the way?
I was thinking
Sure.
about it. Like,
Well, it depends on how precise you need to be. If you only need to go down to the nearest thousandth, you don't need
yeah,
that.
I just found it up there, so I'm not
Sure.
even worried about that. But now that I know how to use it,
Yep.
yeah.
It's okay just to go to the thousandths, yeah. I mean, a lot of times you don't need to go to the 10,000th. That's what that scale there just gives you that extra place. Yeah. Like this said, this is 0.22550, so 0.250. And over here, again, this is between 10 and 11. And because we have the vernier scale, it doesn't matter which one we're closest to. We always go to the smaller one. So that's going to be to the 10. And then So we add that up, 0.260. Then over here, what lines up is the 3. So 0.2603 inches. So this one, let's try this one here in your notes. See how you do. See if we can get that one to go.
That goes over. Does this one go all the way up to 35 then?
Should go up to 25.
That would be 25 then.
So this is 0.3. Do we make it to the 50? No, you can see here we're just short of the 0. It means we have not quite made it to the 50 yet. So it's 0.325. Then this is between the 24 and the 25. Now it looks like we're closer to the 25, but we use the 24 because it's a vernier scale. So we always take the smaller of the two if we're between. So this adds up to 0.349. Then what lines up on the vernier scale is the 7. So what that's saying is that's actually 24.7 is where that's at. So 0.3497 inches. Now, of course, the nice thing on these examples is we have the pink line that tells you which one of the vernier lines lines up. The real micrometer, they don't just automatically turn pink on you. Darn it. So this one, 0.4, is it 7.5?
450.
Why is it 7.5? We just passed the 0. Now, again, it's between 0 and 1, so we're just going to leave it at 0, so we don't have to add anything, and then it's the 4 that lines up. So 0.4754. So that's reading.
Smallest number, even though 0 is not a number.
Yeah. So then, calipers. Remember this one, you read it at the notch here, not at the edge of the jaw. Is this metric or standard?
Standard.
This is 0.01 millimeters. This is metric. So this is not 4, it is 40, 41, 42, 43, 44.85. This one, 35.81. Those are all millimeters. So this one is going to be 15, 16, 17, 18, 19.48. How about this one? 31, 32, 33.56. Try these two in your notes quick.
Nope. I have a quick question. You know, like Kristen has a tape?
Yep.
I seen something like this, and I'm like, So I just take these. Well, I just made
Yep. 2.3 times 2.3.
3, and then
Then
just
you
10.
add 3 plus 3 is 10 to the 6th.
Yeah. Oh, okay. So that's.
Yep.
Right.
And then
I
if
thought
you-
you had to do this and then do this and then add them together, but you can just do the 6. 3 plus 3 is 6.
Now, if your number has more than one decimal point, more than one digit for the decimal point, you might have to move the decimal point to adjust the power of 10.
So what if it's like this and it's got like something like that? Do we have anything like
And then
that?
yeah, you do. Well, not on the quiz, you won't. No, I won't do that to you on a quiz or a test right now.
Oh,
That'd be the next step. We haven't got to yet. Okay, so for this one, we have 13.66. And this one, 38.52. Very good. How many got both of those right? We're doing good on these? We skip to the next one? Looking at this one, you might see a difference. What's the difference? Yeah, first of all, the dial says 0.001 inches. And there's two different numbers scales here. So this is inch. So this is 1.2 and then 62, 1.262 inches. This one is 0.7 actually. Then what? 0.777. So 2.3 and 53. Here we have 1.569. Looking familiar? Again, the biggest problem is just getting the decimal point in the right spot on these. So try these two in your notes quick. Okay, so this one is 2 point, what? Is it 2.1? No, it's 2.099. This one is 1.763. Great. How many had both of those right? Good deal. How about these?
Those are standard.
These are vernier. This is a standard. Actually, this is not standard. This is metric.
Dang it.
This is 30. This would be 35. Now, we read the main scale if we have a vernier caliper. Now, I'm never going to test you on the vernier caliper. I may put a vernier micrometer on there, but never a vernier caliper. Just because they just don't get used that much anymore. But we read the main scale of the vernier caliper at the 0 of the vernier scale. So this right here is 31, 32. Point, we see what lines up down here. Looks like this one lines up, right? The 6. So that's 32.6. millimeters. This one's really close, isn't it? So is this one. Generally what you do is if you have 3 of them that are really close to being lined up, it's usually the middle one that is lined up. Now what I a lot of times do is I have to take them and I have to tip them like this and actually look right down the lines, and then you can see if they're just slightly off. This one I won't quiz you on. I just want you to be exposed to it. So here's the 0. This is 25. So that's past the 25. Point. What lines up here? So it's either this one or this one, right?
I'd say the 1.
I'm saying this one right here. That's not the one. That's actually the 1.5. That's 25.15 millimeters. See, this was at the 6. That's actually 6.0. That's 60. This is 10, 15, 20, 25, 30, 35, 40, 45, 50. That's what that reads. I know, it takes a little more thought with these, doesn't it? So this is 65, 66, 67. And what lines up is, looks like the 9, right? Is it the 9 or the 8? Looks like
The 8.
I'd say the 8 probably lines up better. 67.80. So then this one, 21 point. What's lining up? Looks like the 6.5. So 21.65. Those are really hard to see in a picture like this, especially when you're looking from the back of the room. Well, like I said, I have to be able to tip it. If I'm looking straight on, I have a really difficult time reading a vernier. Now this one is inches again. This is 1 inch, so we're not to 1 inch yet. This is 0.4. Now this is where the vernier caliper is more like the micrometer, because not only do they have tenths, but there are quarter marks here. So this is 0.475. And then what lines up here looks to be this one, which is the 12. So that's another 12 thousandths. So that's 0.487 inches. That's what I'm getting off of that. Now here's the 2. So this is 1 whole inch, because we're not to the 2 yet. 1.750. And then what lines up here looks like this one, the 6. So 0.006. So 1.756. Oops, that's not millimeters, that's inches. What do you think? Vernier scales are a pain in the butt?
Yep.
Okay. Well, good news is I got a packet for you.
Oh, snaps. Oh, snaps, crackles, pops.
You said it's like digital ones, like the one we were just doing where I wasn't reading the side ones?
Well,
They have like a digital one?
they do have digital ones that go down that far, but like I said, the digital ones, they have to be calibrated a lot because they're very temperature sensitive.
Hey, Tyler.
Yes, sir.
At Walmart, we still got like 3 huge carts full of candy for 50% off. It's crazy. No one has bought any of our candy. It's like surprised.
What am I talking about? What? You know, you can read it. started yesterday too. But let's take a look at that. Now we're gonna try tomorrow.
Tomorrow for sure. I gotta get down.
All right.
To look at this here. So what did I do here on that? Like that.
You gotta look at this one like 3.42. Then he's going to have one digit for the decimal point.
Oh, so like this one.
8.5. So the number got bigger, so the power gets smaller. So negative 4 minus 1 is 8.5. Here, the 3.42. The number gets smaller, so the power gets bigger.